So question for the class is that what is the first order correction to the ground state? This is question 1, and now we are having question 2, that when we introduce perturbation, then what is the first order correction to the ground state? This energy. How much this energy will be perturbed? And we are going to see that thing. So question 2 is that what's the first order correction to the ground state energy, to the ground state energy, and I am writing it as E01. E0 we denote as in the perturbation theory. We have covered this thing, that E0 is the ground state energy, and 1 means that this is the first order correction to that ground state energy. So what it will be, what this correction will be, we will have to calculate, and we know that E01, that E01 is equal to the wave function. So this is 111, and then the perturbation that we have introduced, and again the state here in the kit notation. And this will, when we do calculate this one, it will give us the first order correction to the energy, and H prime I know that this is equal to V naught. So psi 111 and V naught psi 111. I'm going to find out that earlier the ground state energy was equal to this. When I introduce the perturbation, then how much that energy will change, by what amount that energy will change due to this perturbation. And now I can write this thing in an integral form, and this E01 is equal to, in the integral form I will write the psi 111 here. So write the psi 111. What will become psi 111 from here? Psi 111. Nx, ny and nz are equal to 1. So we have 2 over a and 3 over 2 here. Then sine n is 1, so phi x over a. Sine phi x over a. Similarly, sine phi y over a and sine phi z over a. So 111 has given us this thing. Now I can write this in the integral form. So we have this, the V naught will be introduced here. I will have this in the integral form is psi 111 here, psi 111, and it will be in a conjugate form because it's in the brown here. And then H prime is V naught and psi 111 here, and here I will have the corresponding, because we are having dx, dy and dz parameters. So now I can put the values, and I will have to write this thing in a bit simplified form. Here 2 over a, 3 over 2 from this one, and if I take the conjugate, then there is no iota involved, so it will remain as it is. So psi 111 and psi 11, it's a simple square of this thing. So when I square this one, then it will come out, and here I am applying V naught, so the operator which is working here is also not in a derivative form. So it means I can simply take it out because it will do nothing to the psi here during the integration. So I will straight away square this thing, and this is sine naught square will be then equal to 2 over a power 3, and then v naught will be multiplied with this. So 2 over a cube, v naught is being multiplied with this one, and then the square of this. So integral, and x I know that it is from 0 to a over 2, so 0 to a over 2, and this is sine squared and pi x over a and dx. Similarly, the next term, which is 0 to a over 2 for y terms, sine square pi y over a and dy. Similarly, the z term from 0 to a, this one is going to a, so from 0 to a sine square pi z over a and dz here. So we have a very symmetric integral because this is sine squared, this is sine squared. The limits of both are the same. So the result will be the same whether it's x term or it's y term. Here the result, the integral will be the same, but the limits will be different. And here I can use one of the relation, and the relation is that let me write this relation, the integral, so that it can be easier for you. Integral from some limits and then sine square ax dx. This is equal to minus 1 over 2a cos ax and sine ax plus x over 2. This will be the relation here. Now if I look here, what about, okay, here one thing which might confuse, and that is the reason that we have a here and we have a there as well. So let me write this thing as dx. So here it will be dx, then it will be 2b here, and this will be dx, this will be dx as well, and x over 2. So here, if I look here, then in this integral, what is b? b is basically equal to pi over a here. And we are now, means we solve the first integral. So b over a, this is sine square pi x over a over 2. So it means that this thing will come out to be, let me solve the first one and then the next we will just write as it is. So here b is equal to this, and I can now write that for sine square this one I can write because sine square, and then for b I will write pi a and x, and this will be equal to 1 over 2b minus 1 over 2b minus this integral, means let me give it a static. So the static is basically equal to minus 1 over 2, and b is pi over a, and cos of b is pi over a, and x, and sine pi over a and x, and then plus x over 2. Now put the limits. The limits from 0 to a over 2. So when I will put the limit a, then what this will become equal? This is minus 1 over 2, so it will become a over 2 pi minus a over 2 pi, and then this is cos pi over a in a over 2, cos pi over a and a over 2, and then we have sine and pi over a and a over 2 with this one. Okay, pi over a and a over 2. Then we have plus x. So x is a over 2 and 2 here. Now there is some simplification. So here a is gone and we are left with cos pi over 2. So what this will give me? Cos pi a over 2. I know that cos pi by 2 is equal to 0. Sin pi by 2 will give us 1, but cos pi over 2, cos 90, it's equal to 0. And we will have this whole term equal to 0. And only one thing which remains here is this one, which is a over 2, and or let me write this a over 4 because we got a over 4 here. So this term, this integral gave us a over 4. Similarly, this will also give us a over 4. What about the last one? The last one limits are basically different, and that last one will basically give us, I can calculate here what this will give us, the sine square a over 2 when I will put the limit is a. So here we will have minus a over 2 pi here, pi over a, and then for x I will write, means it will be z, so this will be just a here. So a will cancel with a, and I will have cos pi there. Cos pi will come in, and cos pi is minus 1. But here it will come out to be sin pi, and sin pi I know that this is equal to 0. So it means this term will again become 0. And here I will put a over, a means not a over 2 but a here, and then by 2, a by 2. So this will result, this integral will result in a over 2, not a over 4, due to that change in limits. So I have the solution of E01 here is equal to 2 over a cube, then v naught, and then a over 4, and a over 2. So let me simplify this thing then. I see that here a will make a cube, and here this is a cube. So this one is gone. Then this is 2 power 3. 2 power 3 is 8, and 4 2's are 8. So we are left with only v naught over 4. And this is the first order correction to the energy. The energy is now basically E111. So the energy, what's the first order correction to the energy? The energy was equal to E111 here. But when we introduce the perturbation, and the perturbation is that the energy after the perturbation will become the energy will be then E, the ground state energy, plus the first order correction to the ground state energy, and there will be other terms as well, means the second order correction and so on. So this one will become, means the first order correction will now become that when we add this with this, we will add V naught over 4. So this is approximately equal to 3 over 2 and pi squared h bar square over m a squared, and this one plus V naught over 4. So the energy has changed this much with the introduction of the first order correction to this energy. And now the next question that we will handle is that what is the first order correction to the first excited state? This was to the ground state. What is the first order correction to the first excited state? And that we will calculate as well.